right. Hello, everyone. I'm Tyler Dahl. I'm the regional sales manager for the East Coast here for DEWETRON, now a part of Inmitsu, and part of the Inmitsu family as of about October. And today, we'll talk about have our webinar on the latest release of our Oxygen version 6.7. We have new features for everybody, and I have Corey Clark here with me, our senior applications engineer, um, currently out of and live out of the Rhode Island headquarters. One thing really quick, wanted to mention to everybody, so we're going to give everybody a quick poll here. So let us know how you're using the software, how you're using Oxygen, what you use it for, and take a couple seconds. It's just one quick question. Answer that, let us know. And then after the webinar, there'll be a quick little survey for everybody to answer as well. We'd appreciate that. I'll even put in a good word with the big man in the North Pole if you take the time to fill it out. All right, Corey, you want to kick us off here?
Sure. So I'm Corey Clark. I'm the senior applications engineer here. And today what we're going to do is discuss some of the new features with Oxygen 7.7 and Tryon Driver Release 7.7. Some of the new features that we're going to hit today, we have new filter capability with Chebychev filter, type 1 and type 2. We've added some components to our FFT capabilities, or FFT calculations. We've enabled some array statistics now, extension to our Power Advanced package when it comes to harmonics calculations. We have some new data input features to tell you about. And then we have some miscellaneous quality of life features that we've added. And then lastly, we have a page of some bug fixes regarding the Tryon 7.7 drivers and some of our hardware. And so without further ado, we'll jump into the first group of first topic here, which is the Chebychev filters.
All right, so we're going to dig into the Chebychevs. And one thing that is important for everybody here on the call or on the webinar, your feedback is always important. Oxygen is it's for users by users. So all of your input, we take that to heart, and that is how all of these additional features are actually put into the software. So if you have any ideas, would like to see something added, please don't hesitate to reach out to us, and we will gladly take it into account and take a look at it and see if that's something that we can get into the next revision of Oxygen. But that being said, with Chebychev, go ahead, Corey.
All right, thanks, Tyler. So yeah, we're going to go over the slide and one more slide, and then we'll jump into the software, and I'll show you how to enable these filters and where they exist within the software. So first and foremost, we have the two new filters. They're both Chebychev. They're type 1 and type 2. And in Oxygen, we have several types of filters available: low pass, high pass, band pass, and band stop filters. And these filters are available for all of those filter types within the software. And as we mentioned before, this filter is going to be included with Oxygen Basic. So when you upgrade, you'll have it right away. No plugin required. It has an advantage compared to the Bessel and Butterworth filters that exist in the software now, where you have a steeper roll-off after your frequency cutoff point. So it's really good at actually doing the cutoff instead of being a slower roll-off for your filter. And this filter type can be set up all the way to the 10th order as well. So it's almost like a brick filter in a way. So disadvantages compared to Bessel and Butterworth filter. With type 1 Chebychev, you'll have ripples in your passband. And with Chebychev type 2, you'll have ripples in your stop band. And we'll go over some of that in a little bit more depth on the next slide. Some of the specific filter settings that we have for this filter type, we need to set the order. So that's going to set the steepness of our slope. But there's a little, you have to pay for something there, and you're going to end up creating more ripples either in your pass band or your stop band. But we also have a ripple specification, so you can actually set the dB of your ripple so it doesn't get too out of control. You can set that programmatically through the filter setup page. On this next slide here, we just have some of the comparison information and when to use the different types of filters, along with some of the filter response graphs up above. So for comparison, with Bessel filters, they have the worst slope when it comes to roll off after the frequency cutoff point. But there's a trade-off where you have the best phase and impulse response. And what that means is as your signal encroaches on the frequency cutoff point of an IIR filter, you will start to see a phase shift in your signal. So the Bessel is not going to affect the signal as much as the other filter types would. So basically, when to use the Bessel filter is when you need to maintain the signal shape and you don't want to do any kind of attenuation or phase shift near the frequency cutoff point, and if the timing of the signal is critical. Okay. For Butterworth, it's a compromise filter. It's a great all-around filter, smooth passband with a medium roll-off after the frequency cutoff point, and it's pretty much a universal filter. When to use it, you can use it pretty much anytime. It has a clean passband, and there's no ripple in the passband. For Chebychev 1, it has the steepest slope of all the filters, and then you have some ripple in the passband. When we go to set it up in the software, you can think of like the Chebychev's passband. It looks like a whip, where it has the ripples on top, and then it whips up and rolls off very steeply. That steep roll off is great for cutting off the higher frequency content and attenuating it steeply, but you do have to work with that ripple in your passband. All right. For Chebychev 2, you do have that smooth passband, but as you can see in the diagram up top where my blue pointer is, you have the roll off here, and then you have this large ripple in your stop band. So you can see some of the higher frequency components, some of the energy can sneak through that filter because of that ripple there. So when the passband must be smooth, but you can deal with some interference from the higher frequency content, the Chebychev 2 is going to be the filter for you. Okay, and so what we'll do now is I'll stop the presentation and we'll jump into the Oxygen software. And inside of Oxygen, it's pretty straightforward to add the actual filter. And here's the window. Just give me 1 second here. Screen sharing did not work. 1 second. There it is. Okay. Thanks for bearing with me. Okay, so within the Oxygen software itself, if we want to add a filter, we have to go to our data channels menu and select the channel that we would like to perform, add a filter to, actually. So what we would do is come down to one of our cards, like our 1850 multi-card, and we select the checkbox of the channel or channels that we'd like to put a filter on. And we hit the plus button, and we find our filters in the list, and we select IIR filter. And in here, we can see low pass, high pass, band stop, differentiation, and integration. These are the different filter types available in Oxygen. And then for the filter characteristic, we're going to switch from Bessel to Chebychev. Just note that Chebychev 1 and Chebychev 2 both have ripple settings and order settings, but note that Chebychev 2 has ripple in the stop band and Chebychev 1 is ripple in the pass band. All right, and just make note, all of these capabilities are available for use with the Chebychev filters. Once you hit add, you're going to have a filter channel, which is going to show you the filter characteristics. So we'll jump into that now, just so you can take a quick peek at that with me. I'll hit cancel on this, and we'll jump into our filter channel, which is denoted here with the filter header. And so AI13 low pass filter, we'll jump into the setup for it. And once we're in here, we get this nice gain preview. So we could see our group name filters 1. Our filter mode is low pass, and you can change that in here. Our frequency cutoff is set at 500 hertz. Okay. And so our characteristic is Chebychev 2. So we have that flat pass band, and we have our ripple and our stop band. And then we can set our order here. So second order, we get a very gradual slope. And then as you increase the order, you can see that the slope gets a lot more extreme. Now for ripple in the stop band, you can put anywhere from 0 to 80 dB of ripple here. So for instance, if I were to do 10 dB, you can see the stop band is not attenuating much at all. So now we can come down to 80 dB, and now that's going to be extreme attenuation. 10 dB, you're cutting off a lot of the power, but you can still see that some of the energy is going to sneak through there. Now for the Chebychev one, you can see that everything is kind of flipped around on us. We have now ripple in our passband here. And like I was saying, it's like a whip. You have that energy and flips down here for the frequency cutoff point in the roll off of our filter. So this has interesting characteristics where the lower the order, the less the ripple, but you always have that frequency cutoff ripple here at the elbow, and then it comes, or the knee, and it comes down. We have a gradual roll off, but as we increase the order, you can see the rippling increases across the passband, and we get a steeper roll off after the frequency cutoff point. And that would be our Chebychev 1 and 2 filters. And once they're added to this data channels list, this channel can be added to any of our instruments and stored to your data record in your data file. All right, I'll stop sharing the screen here and we'll jump to the next section.
All right, thank you, Corey. So as we can see there, that essentially doubles the filtering capacity, the filtering ability of the Oxygen software. And as with all filters, there are pluses and minuses depending on what exactly you're trying to do and which filter type you're choosing there. So we're going to jump now into the FFT extensions. So our software engineering team have put some additional thought in how you have the ability to manipulate and actually use the FFT tools within Oxygen. And Corey's going to tell us a little bit more about what those additions and what that additional functionality is.
Yeah, thanks, Tyler. So this is, we have a couple slides here for the FFT extensions. First bullet here is a new exponential averaging method, which makes use of tau. So this is an exponential time constant, and this is going to be something that the user can edit. So when we edit the tau value, just keep in mind the smaller the tau value, the more impact the newest spectra has to the actual average for your FFT averaging. The larger the tau, we're going to incorporate more of the older spectra that we have into the calculation, all right, for our actual averaging. Okay, and then we have new overall modes as well for our FFT calculation, where we can do an overall default, which is from measurement start to the measurement end, and we give you overall values for your peak, your RMS, and your exponential average. Then we have now block-based, time-based averaging for the overall modes here as well. So for block-based, it's going to average multiple spectra for a certain number of spectra. For time-based, it's going to do a certain time span for the averaging. All right. Lastly, on this slide, we have a point where we can set to calculate the FFT for a specific frequency range instead of the standard by calculating up to the Nyquist frequency. So this will reduce the amount of calculation that's required by the CPU, freeing up some of the resources on your system. Next slide is going to just let us know that we have increased the data size of our FFT to 2 to the 24th. If you remember, maybe like a year ago now, we increased this to 2 to the 20th to support some of our higher speed cards for when doing the FFT calculations. We've also added a new spectrum type called peak-to-peak amplitude. So this is available for both the spectrum analyzer and our math FFT. All right. Lastly, on this slide, we have had a tool for the spectrum analyzer instrument for a long time, which is reference curves. it's kind of was a misnomer because we didn't really have the ability to make a curve. We were making reference boxes basically. So we'd give the XY coordinate to make a box around your FFT signal. And if you exceeded that, we would change the color of the display as a heads up. Now we can interpolate between the XY coordinates that we provide, so we can actually make a reference curve, which gives you, it's a little bit more practical for what you're doing here with the FFT. Now, lastly, before we jump to the software to show you this, I just wanted to remind everybody, most of these features are for the math FFT, which is available through the data channels list. And we also have the FFT instrument, which is the spectrum analyzer. So there, if you wanted to collect FFT data and store it, we do the math FFT. For just visualizing, we have the spectrum analyzer instrument itself. And with that said, what we'll do is we'll jump back to the software so I can quickly show that to you. And so we'll stop the presentation and then we'll share. And let's see, it worked a little better this time. Here we go. Great. Okay. So what we'll do is access data channels menu. And inside the data channels menu, of course, just like our filters, we're going to select the channel to do a calculation on. And so I'll just select the good old channel 1 here. We'll hit the plus button. And then what we'll do is surf to basic math and then go to FFT right here. Once we're in here, we have all of our settings here, the basic settings. And what we'll do is just hit add, and then that would create your FFT channel. I've already got this created. So it's got, once you hit add, it will create FFT channels, and you'll have your channel list here. And this is an expansion. So you can see your complex FFT values, your amplitude, your overall peak, your overall average, and exponential averaging here. Now, if we click on the setup button for the FFT, we can come in here and see some more of the settings. So example here, we could set the data size, or we can just dictate a line resolution. All right, and that will set up the data size for us. And then on the right-hand side, we can see the FFT output channels. All right, so in here we can enable the amplitude and phase channels. But the ones we talked about on our slide were the overall peak, overall RMS, and the overall exponential average channel. And in here for the overall exponential average, we have the exponential time constant, tau, and we can set a tau value here. And it's in seconds, of course. So I set it for 2 seconds. Now for the calculation mode, I chose to do block-based and a duration of 2 and a minimum in frequency of 0 hertz up to 500 hertz. And it chose not to do any bin reduction at this time. All right. And so once you have that set up, it's just going to generate these channels for your FFT channels here. And so you can take these FFT channels and you can use them for different things. And for example, in here, I took my FFT channels, which are an array, and we have a new feature which we'll get to called array statistics. And I just decided to use the array statistics on that FFT, the amplitude FFT array. And so we could see easily the maximum peak value was 16 volts. The index was 50, which was a frequency value of 100 hertz, since our bin size is 2 hertz. And so we could see on our peak cursor here, we're at 16 volts, and we're at 100 hertz here. So it's a nice way to pull those values out, and they'll be there for you for later on for data analysis and export as well. Now, when it comes to reference curves, as you can see within my FFT here, we can see the red trace, which is the trace we're doing the fast Fourier transform on. And then the orange trace is one of my reference curves. So if I exceed that reference curve, my display will turn orange for me. It's just a visual indication to let you know you've exceeded a value. All right. And now to alter that and change that, we just double click on the instrument, and it'll bring us to the instrument properties page. And in here, you'll have all the properties that you'd like to see for your spectrum analyzer. And so down here with our reference curves, I can click on edit, and this is going to bring up a little screen here where I can add X and Y locations. And I can go through the frequency axis and add X positions with Y amplitude values. And that will draw my reference curve. As I mentioned in the presentation portion, it was a little bit of a misnomer where it was more of a reference box before. And that was because we didn't have the interpolation capability. So if I turn that off, this is what we would see in the past. Oh, we have this, we've exceeded my reference curve here. But now if I do the linear interpolation, which allows me to do a nice slope between our points, we will not be exceeding it now. So it fits this the use case a little bit better here when we're dealing with these FFTs. All right, as always with the reference curves, we can do 2 of them. One will be orange for a warning and red for, oh no, something went wrong. Okay, and so that is some of the features that we went over on the slideshow for the FFT calculations.
All right, thanks, Corey. So what I really like with the new FFT extension, the fact that that interpolation and those interpolation improvements really help with that reference curve. So there's a huge change there. Now, Corey, with the last 2 feature additions that we talked about, do those require any additional licensing or anything?
No, everything here is going to be included with the software, basic package.
That's what I like to hear. All right.
Me
so
too.
Now that being said, you had already kind of hinted to this. Let's dive into array statistics, which is some additional functionality that's been embedded into the array functionality that already existed in our Oxygen software.
Yes, so array functionality has been in Oxygen for quite a long time now. The ability to manipulate arrays started coming into the software after we did our power software package, especially harmonics analysis. People wanted to isolate specific harmonics to do analysis on them, so we started to incorporate array calculations. Now this is going to be our array statistics calculations. So they're pretty straightforward and simple calculations. So what we do is we're going to be able to turn switches on to hunt an array for the minimum value and its element, so its position within the array. The maximum value in its element, we can do the summation of all of the bins or the elements within the array. We could take an average across all of them. We could do the quadratic sum and then the RMS value across all the bins as well. And it's really easy with Oxygen. All you have to do is switch the switches on and then everything's performed for you. And these channels will actually be provided for you, just like we saw with the IIR filters and the FFT calculations. You'll have a separator where it's going to list all those channels for you. And so this is going to be used mainly to hunt for those maximum and minimum values within your array. And so these values will then be stored inside of math channels. And so then we use math channels to do other things, like maybe trigger a recording, trigger an event flag, etc. within the software, or maybe make a little heads-up display for yourself, which I'll show you as well. All right, so let me jump out of the presentation and we'll jump back to the software itself. All right, so back to Oxygen. Let's jump into the data channels. So I created a little array here for you guys. So in Oxygen, you can build formulas using the plus button. And one of the things you can do is it's build an array. So in here, I built a simple array right here. Just open bracket and then add the values. Each value is its own index number, and then you close brackets. You can ignore this over here. It's only there because I'm using some simulated signals today. But below you can preview the array itself. It's just simply climbing in value. All right. Now I wanted to do some array statistics to this channel, and so I select it with the checkbox, go to add a channel, And I want to use the new search bar up top. This is another feature. I'm kind of jumping the shark here. But if I don't want to scroll through this list, I can type in array and get array statistics here. Okay. And once we have array statistics, we just simply hit the switch. And we turn these switches on. And we get all the channels that we would like to get out of this. And so I'm going to hit cancel like always and show you the one I've created already. And so in here's array statistics 1 here. So this is my array. It's referencing the name of the formula down below. So my array min, minimum index, max, max index, sum, and average. All right, and these channels can all be used in digital meters or time displays as well. So what we'll do is go back to the measurement screen, and I'll switch to measurement screen 1 that I have here. And we can see our simple array of values. And then down below, I've used out of my channel list here, we can see our array statistics here listed. And I've just dropped these values into some digital meter group here. And we can see my array minimum value is at index 0. You can see index 0 has a value of 1. My array max has 9. 9 we come across. We can see that's at index 8, and it reflects it here in the digital meter. And then the summation of these values together is 45, and the average of these values is 5. So that's just a nice little example of what you can do with array statistics to look for these values. Now, a little bit more involved thing that you can do when it comes to real data, or if you're looking at an array of data in Oxygen, for instance, our FFT. Remember, the FFT is an array of values, and we can use the array statistics like I did down here, just like I showed you on the last screen. And so what we could do is we can hunt for the peak value, and we could say if the peak value of our array or our FFT exceeds a certain value, we can then do a trigger or output a certain value or enumerated value. And I did that in a display down below. So I said, is the peak value of my FFT array greater than 12? And then it's true, and it shows a little checkbox here. Now, to do something like that, it's pretty straightforward. What we do is we come into our math formula screen, and then we can use our math formula page to do an if statement just to compare the value. And so we're going to say if the FFT peak max value is greater than 12, we'll output a 1 or a 0 if false. And then we can come into our enumerated label editor, and we can create these special labels for ourselves for our digital meters. So on a value of 1, it's true. On a value of 0, it's false. And we get a nice picture here. All right. And so that's what I did here. So now we can extract the value of that array, and then we can test it against something else and then provide an output to a user or the user of the system, or to do something with the software like set a marker or maybe stop the recording. All right. And so that is the array statistics.
Great. Thanks, Corey. All right. Now we're about halfway through our webinar here, and wanted to see and mention to everybody, so we do have a Q&A section. So if anybody has any questions about the FFT functionality, the arrays, or the additional Chebychev filtering that's been added as a feature to the software, please don't hesitate to enter that in the Q&A section of this presentation. And then, of course, we'll get to those questions at the end of the presentation. Now we're going to jump right into the power extensions. So this is going to be a good one, because I saw through the poll that we did at the beginning of this webinar that there are a couple people here who are using DEWETRON systems and the Oxygen software for power calculations. And we're going to talk about the new power extensions, and these are specifically around harmonics and some really cool stuff here.
Yeah, thanks, Tyler. So in Oxygen 7.7, we've done some power extensions when it comes to the harmonic and interharmonic calculations, as well as the superharmonics. So basically, typically, if we look at this table on the left-hand side of the slide, Depending on the fundamental, we do incorporate a certain number of periods into the harmonics and interharmonic calculations, as you can see here. Okay, so when we're working in, to 60 hertz, we're going to be doing 12 periods for that calculation. If we're in 50 hertz land, we'll be at 10 periods. Now, these take up a lot of resources for calculations, and the calculation can be a little slower than you need. So if you need to increase the speed of these calculations, we have the fast setting now for the harmonics update rate. And essentially, if you turn that to fast, what we're doing, if you look down this list and compare it to the first column, we're just cutting the number of periods in half that we use for this calculation. So it's pretty straightforward. And so it's just going to reduce the amount of time it takes for those calculations to be performed. All right, so if that's something that you need, it's now in the software for you. And secondly, on this page, we have the higher resolution for our supraharmonics calculation. So instead of doing the resolution of 2 kilohertz for the calculation, we're going to be able to up that to 200 hertz for the resolution. Once we up that to 200 hertz, this is going to just ensure that you're in compliance with the IEC 61000-2-4 standard 2024-6. Okay. And that's it for the power extensions.
All right.
I should just add one little thing. These are in the advanced settings. For those of you who know how to access that, let me just take a second here to show you how to do that. I should do that too. So stop this presentation. Let me jump over to the software quick. This will be really quick, but I feel like it's beneficial. So what we'll do is, if you have a power group created right here, for instance, and we go to setup. Within your power group creation screen, we have that settings tab above our different power networks. All right, so settings. Once we come to settings, we see all our sync settings for setting up our sync source. We have our advanced settings here. And so if you're using and enjoying Oxygen Power Advanced and Expert, you'll be able to interact with these settings over here. So we come to harmonics, we enable it with the switch, and then we can set our grouping type. And then down here, we can set our harmonic and THD harmonic order. And then we can select our harmonics update rate, and that's where it is, default or fast. Just remember the amount of periods is reduced for that fast calculation. And for the super harmonics, we have to turn on our switch, and then we can change our resolution using the radio buttons here from 2 kilohertz to 200 hertz. All right. And so I just wanted to show you that quickly. And so let's get back to our presentation.
All right. Thank you, Corey.
Yep.
So one thing important to note with the new power feature extensions that we got there is that is in addition to the original calculations. So if you do prefer the way that the harmonics were calculated originally, you can keep that as well as the defaults, or you can choose the new faster method that is probably especially helpful when you're calculating your harmonics out to the higher orders.
Cool. Thanks.
All right. Now let's get into some of the new data import features that have been implemented into Oxygen 7.7. We all love our data. We need our data. That's why we're all here. And being able to pull in data from external sources can be just as important as the data that we're actively looking at. So Corey?
Yes. As we go through time, some equipment gets older. We may need to move on to newer equipment like DEWETRON equipment, and it may not use the same file types, but you want to retain that data and you want to be able to visualize it. So you can visualize it in the new software package, Oxygen. And we've added some features to allow you to do that. We've had a feature called our CSV import filter for quite some time, so we could import CSV data. But we've added text import as well. So if you have a text file, you can now bring that into Oxygen and save it as a DMD file as well. We've also incorporated the import of DXD and D7D data files. These were data file types from our legacy data acquisition software that we stopped providing, around 2014. But we have a user base that still makes use of this. So if they want to upgrade and move on to the new software, some of the concerns are, how do I view my old data? And well, now we can do that with this new import tool, which is really nice. And so when you import these files, you'll be able to save them as the new DMD DEWETRON measurement data files and open them and view them in Oxygen. All right. Remember, viewer licenses aren't a thing at DEWETRON, so you can install Oxygen on any PC. And as long as you recorded the file on a licensed system, you can share it with anybody within your company, and they can edit the file as if they were on the licensed machine itself, which is really nice. Now, some of the things that you can do with these files is you can change the time base and offset, so you can align the start of the file as absolute time or as relative time, so you can help get that time aligned properly within your DMD file. This is also beneficial too, because in Oxygen we have a capability to open multiple data files within one instance of Oxygen to compare files. So if you had a bunch of older data files that you wanted to compare, you can import all of them at the same time into one file to do comparisons with that as well. It's just another feature that I felt should be mentioned here because it ties together so nicely. And so those are the new data import features for Oxygen 7.7.
All right. So I really like that one, especially you had kind of touched on this, Corey. If you have legacy data files, so data files from older systems that data is still important to you, or maybe there's reference data within each of those files that you want to have access to for a current test that you're performing on a piece of equipment or in a certain scenario. Being able to go back and look at that data and actually look at that data side by side, that's of huge value.
It is.
All right. So now we're going to dive into the miscellaneous functionality that has been added. So as always, Oxygen is for the user, by the user. And a lot of the functionality that has been implemented is based upon feedback from current Oxygen users. And a lot of this actually runs into that or stems from that. And you'll see a lot of these kind of, overall helping with workflow or just quality of life kind of changes or improvements that have happened to the software.
Yes, exactly. So thanks, Tyler. Yeah, so Oxygen is all about, testing efficiency. So we want to make it easy for you. We want to make it fast and intuitive. And so these miscellaneous features, like Tyler said, are quality of life things. We listen to the users. We make changes based on your feedback. So we love that feedback. Please send it in to us whenever you can. We really appreciate it. But to get to the slide here, the first point on here is for multi-file recording. Within Oxygen, we have the ability to create multi-file recordings. And this allows us to split files based on size, event types, etc. And the new multi-file recording option is splitting by file size. So that's something that hasn't been in the software. Some people have asked for it, so we've added it. And it's just what it's going to do is you'll be able to hit record. And then when your file gets to, say, 500 megabytes, it'll create a new file that will be named the same, and it will have a value on the end of 0, 1, 2, 3 to increment up as you get new multi-file recordings. These files can be stored in a subfolder that you can use a switch in Oxygen to select, and that will create a special subfolder for that multi-file recording, and it will make it easy to find it and then also review those files. And so you can review these files independently, one at a time, or you can select them all and stitch them back together to view them all contiguously within Oxygen. Just sets you up for doing a massive export at the end of the day if you wanted to, or to review the whole file at one shot right there. Now for order analysis, there's a new calculation type available. It's basically the possibility to switch between amplitude RMS to amplitude or amplitude peak to peak. So those exist now for our order analysis users. And then we have a new instrument property option. So when you do network systems with multiple chassis, what will happen is your channel names will get quite long because we reference the channel name as well as the chassis name as well. All right, so in the image down below in the center where my blue dot is, you can see AI11 at DEWE3RM16 underscore 056. This is channel 1 of card 1 on that unit that may be out in the field on the network. That's a long channel name, and sometimes these channel names, you can't really make them out or see them very well in the instruments. So if you wanted to make dedicated page and oxygen for specific chassis on our net option setup, then you can do that, and that way you don't need to have those long channel names. So within the instrument properties, we have a checkbox now that says show short channel name. So if I wanted to dedicate a page to those channels, I could just see them as just analog input channel names. It makes it a little bit easier to see things. As the picture shows, it's not too bad because it's AI11, but if you were to name that strain gauge 1, the name gets longer and longer and longer, and it can be hard to see. So now that's in there. It's a great little quality of life improvement. For GPS plots, something we've had is color gradient for the GPS plots. So for your trace for your vehicle on the map, we could change the color, so based off of speed, for instance, you can change the color. One of our customers had requested for a very special application they were doing to have a two-sided color gradient. So this color gradient is going to allow them to do, a center value and then go to a color for the max and then go to a separate color for the minimum. And so you can effectively use the color gradient for the full range of the readings, positive and negative, of a center value. All right, so that's really helpful, and that's just been added to our GPS plots. On the next slide, for some more Miscs, we have recorder cursors. So in our recorders, we have the ability to show statistics values. So max, min, RMS, ACRMS, average values. And we can do cursors. So we could do cursor positions and get the values there and then do calculations between your cursors. Before, when we had a recorder showing statistics values and we enabled the cursors, we'd still see the actual raw values in the cursor boxes. So it's something we've updated now. So if you're making use of the statistics within your recorder, you'll actually be able to do cursor calculations on those statistics. For our Modbus users, we've increased the polling rate from 10 hertz to 100 hertz. And for CAN FD users that are making use of ARXML files, our decoding now also supports container and secured PDUs. And then the next one's for exporting for CSV, text, and XLSX exports. We have the option now to skip timestamps during export. And then one of the functions, this last bullet here that I showed you already, was a search function in the add channel dialog. So you could type in filters and it would bring up IIR and FIR filters for you. And we have one more slide here for our Miscs. On this slide, the top bullet here is regarding Trinet 3 devices. If you have multiple Trinet 3s with the same cards inside, when you would take one Trinet off of your computer and maybe take another one and plug it in, the hardware mismatch dialog would pop up. And for our users that haven't seen that yet, it's basically if you move your cards around in the chassis, we bring a dialog up for you when you load a setup file, allowing you to remap your analog input cards to the correct positions because they've been moved in the chassis. So you don't have to recreate your whole setup file again. In the instance of the Trion nets, when we're swapping them in and out, there's no need for that, and it just creates confusion. So we've decided to suppress that dialog for that instance. You can always force it to come back on through the option inside of Oxygen. Also, CAN messages are matched to synchronous channels to reduce the data rate export. For people using our simplified XML setup, you can now set your parameters for the filters that are on your DAC-P modules. These are signal conditioning modules that would be out in front of something like our Trion or Trion 3 1802 DLV card. Before, you were only able to set up the DLV cards filter settings, but now you can actually set up all of the DAC-P module filter settings. And you could do that with our Orion cards as well. For those of our customers that are using PAC, we have a PAC Live plugin that we can stream data over to the PAC software. And so we can send PTP time source and PTP out whenever that is active. And for fur filters, we have saturation detection. The extension of limit when displaying not a number has been set to 99.9%. And that would round out our miscellaneous features for 7.7.
All right. I really like the ability to change or break off your by file size now. I mean, that's huge, especially if you're doing any exports or just exporting to network drives. It makes that transfer of that data and those files much easier.
More predictable for sure.
Absolutely. I know that's good stuff. Now, as we've had users who have found, like I said, by the user, some of our users were able to find bugs just from kind of testing Oxygen to its maximum abilities. And our software team has worked with this revision to fix some of those bugs. And Corey's going to go over some of those bug fixes that we've covered.
Yeah, thanks, Tyler. So with our Trion Driver 7.7 release, there's going to be some firmware updates available. So if you're upgrading, be sure to jump into your DEWETRON Explorer once you've installed the new drivers. Once you jump in there, you may see some of your cards or even your chassis controller shown as red. If you know me, I say red does not mean dead. And the DEWETRON Explorer, it means that you have a firmware update available. So please select it and proceed with that firmware to gain these benefits. Some of the benefits revolving around the Trion 3 chassis controller, which are listed at the top 3 bullets here. One of them is a fix for the frequency output not working. We had a fix for the iRig synchronization frequency jump, and then a fix for PTP master cold starts with showing an invalid sync signal. These have all been corrected, and there's a firmware update available for that to enjoy this fix. For the power boards themselves, Trion 3 power boards, on our sub-XV modules, which are our auto-ranging 600-volt RMS submodules, there was a wrong readings at 3 megasamples. Another fix for the power board was there were some spikes on some channels that were seen, and that was a firmware fix. And then for the power and sub CT, there was an offset jump that was occurring when you'd restart the system a couple times, and that's been fixed as well. For the sub XV itself, the Trion sub XV, you'd put a measurement scaling in, and sometimes it would be actually wrong, seen as wrong from the software's point of view, and that's been fixed. For some of our original boards, the Trion 1620 LV and ACC, there was a DC to DC control failure that would occur, and that's been fixed. And then the DEWETRON Explorer itself. So the DEWETRON Explorer is that second software package I've already mentioned to jump into for your firmware updates and status checks of your hardware. In that software, you can set up your network settings for your TrionNet devices. So TrionNet and TrionNet 3. And in there, you can set static IPs, addresses, and subnet mask information for your TriNet devices through the network settings window. Unfortunately, in the last versions, the network setting window was not loading your PC's actual settings, so you'd have to do everything through the PC controls for your network and sharing center. And now that's been fixed in the DEWETRON Explorer itself. And that would round out the miscellaneous bug fixes for TriNDrivers 7.7. Shows our team's hard at work.
Awesome. Thank you, Corey. Did an awesome job
welcome.
as always. That's why I lovingly call you the brain.
Thank you.
All right. Now, for everybody on the call, don't forget the download for the latest revision of Oxygen is now available through our customer care site. So that's ccc.dewetron.com. You can find it there. And that revision comes at zero cost to everybody who is currently on Major Revision 7. So all minor revisions within the Major Revision come at all of our users, or are available to all of our users. So if you can't find that download, feel free to reach out. We can point you in the right direction, and reach out to anybody here at DEWETRON. We'll be happy to help. And please don't forget, going to get a quick survey here at the end of this presentation. We'd appreciate if you fill that out. Santa Claus is watching. So like I said, I'll put in a good word, fill it out. And I'd just like to thank everybody for their time with participating and attending the webinar. And I hope everybody has an awesome rest of your day.
Thanks, everyone.